Right. Fifth question, I have one mass here, one mass here. Right. Now, center of mass of these two particles will be here. Center of mass of these two particles will be here. But what will center of gravity be? Center of gravity is the point at which gravitational force is acting. Now, gravitational force acting on it is 0. Gravitational force acting on it is mg. So, this will be center of gravity for the two particle system because this will be 0. Gravitational force at the center of the earth is 0. So, center of mass will be here, center of gravity will be here. They are just playing a practical joke with you people. Above all, what is the basic difference between the two? If this is earth, if I take a thin rod of this large dimension, center of mass will be at a distance of L by 2. But center of gravity here will be slightly lesser. Why? G is varying. As I am going up, the G value is decreasing. Is that clear? How can I calculate center of gravity? Right now you will not be able to calculate. Temporarily understand the concept. Nothing to do about the calculation. You have only calculation of center of mass in your syllabus. Right? Now, seventh one. Force of attraction of F1 on a particle at a distance of 3r from the center. What is wrong in 7th year? You don't want to attempt the problem, that's all. Because of the whole of the sphere, find out force. Because of the leftover sphere, find out force. How do you calculate the force due to the leftover sphere? Complete minus this. Find out the field here. Complete sphere's field, E complete minus E cavity. This into small m will give me F2. F1 I know. Please try, attempt. Something that has been covered in the class. Then 3-point masses. See, they are going about in a circular track like this. That means this force I will call it F1, this force I will call it F2. People sitting here, if they cannot keep quiet, please leave to the other. This is one force, this is one force. Resultant of these two will be towards the center. That provides the required centripetal force. Can I calculate F1? Can I calculate F2? Can I resolve both of them towards the center? Equate it to mv square by r. That provides the required centripetal force. Loss in potential energy is gain in kinetic energy. 13. You are taking a particle from here, small m. Particle starts from rest at a distance of capital R from the center along the axis. Velocity at the center of the ring. Do I know the potential here? Do I know the potential at the center? Delta V into m will be equal to delta U, which will be equal to delta K. Loss in potential energy is equal to gain in kinetic energy, half mv square. Velocity is being asked. Potential here if we know, potential here if we know, difference into small m will give me, right?
It's the ninth one.
Ninth one is a good question. Understand one logic here. This is capital M. Particle of mass capital M is at a distance from the surface of a thin spherical shell. Gravitational field and potential both are 0 at the center. Remember, gravitational field is 0 because of the shell. Because of this there will be a field inside. In ninth, the only doubt that you people will get is, how is the field inside the shell non-zero? Field inside the shell because of the shell is 0. But because of capital M there will be a field. Is that clear?
Yes, sir.
17. Artificial satellite of Earth releases a package. If the air resistance is neglected, the point where the package will hit, artificial satellite releases a package that will also become a satellite. It will have the same orbital velocity. Right? Let's see, we asked you a nut or a bolt released from a satellite. It will also become a satellite. It will not hit the ground. 20. Suppose a smooth tunnel is stuck along a straight line passing through 2 points on the surface of the Earth and a particle is dropped. Assume that the mass of Earth is uniformly distributed as the particle will emerge from the other end with a velocity. There is no particle will come to rest at the center of the tunnel because no potential energy of the particle will be equal to 0 at the center of the tunnel. No acceleration of the particle will be proportional to its distance from the midpoint of the tunnel. ये किया है ना यार class में, we proved it is SHM. We calculated the distance. Who got 20th as a doubt? Can you people have a look at your class note once before starting these problems? We calculated a particle performing SHM along the tunnel. First, hollow spherical shell is compressed to half its radius. Gravitational potential at the center. Hollow spherical shell is compressed. Potential, whatever is on the surface, everywhere inside it will be the same. Hollow spherical shell is compressed to half its radius. Half its radius. Potential is minus gm by r. This is the potential on the surface. Or, right, mass will remain the same. Right, radius has decreased. Minus gm by r by 2. Just don't forget to take the negative sign into consideration. People who think r by 2, r decreased, potential will increase are wrong because of the negative sign. 23. Two satellites in the same circular orbit around the Earth. This is a genuine doubt. You will get this as a doubt. Listen to it. Are revolving in opposite sense when they undergo complete inelastic collision. The combination complete inelastic collision. See, they collide this way. Their velocity will decrease. Inelastic collision. Kinetic energy will be lost. Their velocity will decrease. If their velocity will decrease, it will go in an elliptical orbit inside. Only if the velocity increases, it can go into an elliptical orbit like this, or a parabola, or a hyperbola, or a straight line. But for that, velocity should increase. Here this velocity is decreasing. It will be a bound orbit. What do you mean by a bound orbit? Kinetic energy plus potential energy should be negative. For a bound orbit, kinetic energy plus potential energy should be negative. Make a note of it. Note. For a bound orbit, kinetic energy plus potential energy should be negative. Hence 23rd, this particle will go in an elliptical orbit this way. We have drawn these diagrams in your class notes. The satellite of mass 5m orbits the Earth in a circular orbit. At one point in its orbit, satellite explodes into two pieces. One of the conserve momentum here. Listen. One is some 5m mass is split into two. Right? M and 4m. Can I conserve momentum in the horizontal direction? Please find out. One of the masses, he says, one of the piece capital M and the other with after explosion mass capital M ends up traveling in the same orbit. Capital M will end up traveling in the same orbit. That means I know the velocity. 5m into V0 will be small m into V0 plus 4m into V dash. Find out V dash from here. the V dash, if it is greater than the escape velocity, it will escape, right? If it is lesser than the escape velocity, then it will continue in an elliptical orbit, right? Here I think it will be equal to the escape velocity or greater than that. Minus V naught. So now V dash will be in an elliptical orbit, or is it greater than escape velocity? It is greater than escape velocity. So unbound orbit, it will escape from Earth's gravity.
Sir, what is partially bound orbit?
Partially bound orbit technically is not defined. This questions have been picked up from this materials from Kota, hence they use this language partially bound orbit to explain elliptical orbit. Right? To explain elliptical orbit. But we will call it even elliptical orbit as bound orbit only, because total energy will remain negative.
Sir, can you repeat this question?
Conserve momentum in the horizontal direction. Find out the velocity of 4m, that will be greater than escape velocity. Find out velocity of 4m, that will be greater than escape velocity. Anything which escapes is not in a bound orbit. Clear? No, need not be. We have drawn one. If it is greater than orbital velocity, lesser than escape velocity, it will go this way. Less than it will naturally.
Sir, how can we conserve momentum? There is a force acting on it by the earth, right?
Vertical direction. You are conserving momentum in horizontal direction.
Oh, okay, thank you.
32. Hey, 32 time period 2 pi r by v naught. Did we deal with binary star system?
Yes, sir.
Omega in the binary star system. Look at your class notes. Binary star system में whatever you got as omega, can calculate time period from that.
Sir? Sir, I didn't understand the position of center of gravity in the fifth one.
Center of gravity में this is a tunnel dug. The weight of the particle here is 0, while this is mg. So center of gravity is concentrated here because this is 0, while center of mass will be here. Mass of this particle will contribute to no gravitational force. At the center g is 0.
Sir, 30th.
Exercise 2 में there is no 30th, here there are only 10.
Sir, exercise 1.
You don't refer to your class notes ever, right? See the derivation of angular momentum for Kepler's second law. That's the derivation. Have a look at your class notes once. That's the derivation of angular momentum. dA by dt is L by 2m.
Sir?
Yeah.
So, what is proper potential energy?
What?
What is proper potential energy?
I don't know
Proper
anything
potential
called
energy.
improper potential energy doesn't exist. There's only one potential energy. What do you mean by proper potential energy?
So, there's a question in Erodo. So, find the proper potential energy of gravitational interaction of matter forming.
There he meant there are two types. Here you will have, I yet didn't define self energy for you. Wait till electrostatics is done. We will define two forms of potential energy there, self energy and interacting potential energy. So what he means there is interacting potential energy. But wait till electrostatics is dealt with.
Sir?
Exercise 2/5. Communication satellite, Earth satellite. It should be rotating in the direction of Earth's rotation. Communication Earth satellite should be in the direction of Earth's rotation, west to east. Can be in the equatorial plane only. Yes, can be vertically above any place on the earth, goes around the earth from west to east. Communication earth satellite generally is a geostationary satellite. Hence he applied the conditions of geostationary.
Excuse me, sir.
Yeah.
So in class we had done a sum where there's a combination of a semicircular ring and two semi-infinite wires. So you said it was from Erodo, but I can't find it in Erodo.
Now I shall show him. Somebody give me a look. These people are taking me for a ride. How do I show it to him?
Page number and question.
Page numbers will change from different editions. Page number will change in different editions. Hope he is able to see that. Okay, search for the 15th question in electrodynamics. Search for the 15th question in electrodynamics. He gave that question in electrodynamics and not gravitation. 15th question in electrodynamics. One second. Somebody said question 3. Question 3 is an important one. You will generally have that as a doubt. Listen. Question 3. Gravitational potential at the center of curvature of a hemispherical bowl. Let me orthodoxly solve this. Though you can make a guess. Every small element of the hemisphere from the center is at the same distance. So it is minus gm by r. Right. But then if I were to solve this traditionally, all of you please have a look at it. Let me solve it traditionally so that you will never have this doubt again. See, this is theta, this is d theta. The radius of this ring is r sin theta. Thickness is r d theta. Distance from here till here will be r cos theta. Now this ring that you considered in a hemisphere, because of that the potential is minus g dm by this distance will be r. Am I right? Potential due to a ring is minus gm by under root a square plus x square. A is r sin theta, x is r cos theta. Summation and squaring I will get this. Now if I integrate this, I will get minus gm by r. Right? Yes or no?
Yes, sir.
Now one more point. Gravitational potential at center of curvature of a thin uniform wire of mass m is bent in the semicircle of radius r is also equal to v. Gravitational potential of a semicircle. Gravitational potential at the center of curvature of a thin uniform wire of mass m bent into the form of semicircle. Now here also if you see, every small element is at the same distance. So the potential will be minus gm by r. But see, what creates a confusion is the same wire mass in, if the same wire is bent into a quarter of a circle, please observe, don't compress this wire and make it a greater radius. You are not compressing the wire and making the same wire, I am not making it into a quarter of a circle, the radius will change. He is not doing that. What he did is, quarter of a circle, he bent this part of the wire over the other. He bent this part of the wire over the other. Now potential will be the same. You understood what he meant by bending? You can bend this wire this way. Suppose I have a semicircle this way. Right? This part I bent it over this. You are bending this part of the semicircle over this. Is that clear?
Yes, sir.
Next.
Question 9.
Question 9. Satellite S is moving in an elliptical orbit around the Earth. Mass of the satellite is very small compared to the mass of Earth. Acceleration of S is always directed towards the center of the Earth. Angular momentum of yes about the center of the earth changes in direction but its magnitude remains constant. Wrong. Angular momentum will always remain in the same. Satellite is rotating in the same direction all throughout. So angular momentum direction will always be the same. Total mechanical energy varies periodically with time. Total mechanical energy remains constant. The linear momentum of S remains constant in magnitude. No, the velocity may be changing. Did he say circular orbit, elliptical orbit? So linear momentum will be changing. Clear?
Sir, second question.
Three particles projected vertically upwards from a point on the surface of Earth with velocity is this. Radius r is the radius of Earth. Right? The maximum height attained respectively. I am projecting this with a velocity v. Half mv square minus g capital M small m by r. The maximum height will be minus g capital M small m by h. Equate this to this. Substitute the value of v given, equate this to this. Right?
So the seventh on C part.
7. Two satellites of same mass of a planet in circular orbit have periods of revolution 32 days and 256 days. Right, if the radius of the orbit of the first is x, दिक्कत क्या है यार, t square directly proportional to r cube.
So C option.
Total mechanical energy of the second is greater than that of the first. They are in different radii, no यार.
So velocity नहीं दिया हुआ है. तो मतलब इसमें kinetic energy consider करेंगे क्या?
क्यों नहीं करेंगे? कुछ भी. See, here I have half mv square minus g capital M small m by x. Here I will have half m v dash square minus g capital M small m by say 3x, 4x or something greater y. You have done this in Bohr's atomic model innumerable number of times. Energy in the nth orbit, the negative sign is important. कर के पक गए होंगे यार. How can you ask this as a doubt? I don't understand. Did you do that in Bohr's atomic model? Energy in the nth orbit, energy in the mth orbit, negative sign in front of it should be taken into consideration. As you are going away, energy increases or decreases. बहुत करते हैं Bohr's atomic model में. Yes or no?
Yes sir.
So, can you please repeat the question 3?
Question 3. Which bit of that do you want? Hemisphere.
The C part.
This is the wire. Bend this wire over this. This part of the wire I am bending it over this. So potential will be the same here. When I am bending this wire over it, potential will be the same here. Because the mass distribution is the same. Every small element is at the same distance of r from the center.
So, the C part.
Non-uniformly distributed along its length is bent in the semicircle. How will your answer change here? C part you are continuously insisting. See, this element is at a distance of r. This element is at a distance of r. This element is at a distance of r. Now if I add up all of that, I will get the total mass, whether it is uniformly or non-uniformly distributed. अब सोच नहीं रहो यार. However it is distributed, answer will be the same. Here I have got dm1, here I have got dm2, I have got dm3. Let it be non-uniformly distributed, but sum of whole of that will give me m, right? So potential due to each one of them is minus g dm by r. You integrate that, whether it is uniform or non-uniform, answer will be the same.
Thank you, sir.
If a satellite orbits as close to the Earth's surface as possible, total mechanical energy of the Earth plus satellite system is minimum. Same question, you answer this to me. Bohr's atomic model में this was the nucleus, right? where do you think energy will be greater for n equal to 1 or n equal to 3? N equal to 3, sure. मैग्नीट्यूड से लेना देना है नहीं बेटा मुझे. दिस इज -13.6 माइनस हाइड्रोजन एटम नेक्स्ट
3.4.
अरे यार हाइड्रोजन एटम सेकंड ऑर्बिट ऑफ हाइड्रोजन एटम एनर्जी minus 3.4 1.5. Right, this should be on the tip of your tongue. Same thing applies to gravitation. Kinetic energy as well as potential energy put together. What is G? You will replace with G m1 m2 by R, potential energy. There it will be K q1 q2 by R. Isn't it? So in fact your answer is correct. N equal to 3 will have greater energy. Right? That's why an electron from higher orbit, when it comes to the lower orbit, it releases energy. So here N equal to 3 will have greater energy when compared to N equal to 1. So when a satellite is very close to the Earth's surface, the energy will be lesser. Convinced?
Yes, sir. Yes. So in the third question, if we are asked to calculate the field, will it be same?
Need not be the same. Field will even have direction. So non-uniform mass distribution will not give you the same field.
Suppose a satellite comes from higher orbit to lower orbit, it will emit energy, right? So where does that energy go?
It's like we give energy, indirectly we are taking away energy from this. Spring mass system में mass going to the right or left, I should be doing work. One will be positive, one will be negative work. To bring a satellite from higher orbit to lower orbit, we should be doing negative work on it. So people didn't solve exercise 3. Exercise 3.
Sir, see.
If U is the potential energy and K is the kinetic energy. Pardon? Question number 2, exercise 3. Magnitude of U and magnitude of K. Just imagine, U will always be negative, total energy will always be negative in a bound orbit. So this plus this should be a negative quantity. That means kinetic energy should be lesser than. For this total quantity to be negative, always magnitude of U should be greater than the magnitude of K. Yes or no? Potential energy is negative. Total energy should be negative in a bound orbit. So obviously magnitude of U should always be greater than magnitude of. Wonderful, right?
Yes, sir.
Next.
14.
Sir, see.
Ah.
Second question, which option will be the answer?
C. Second
C will be the answer. You are unfair here. I am telling you all throughout the orbit this will be true. You are asking me which is the answer in the second question. All throughout the orbit this will be true. You take any 2 points, this will be true. You are asking me what is the answer in the second question. Somebody said 6.
So question 8.
Sir, sixth question, sir.
Sixth, the work done on the companion star in one complete orbit by the gravitational force of the black hole equals 0. Now here it is always perpendicular. Circular motion we have learned. Force perpendicular to displacement, work done will be 0.
Sir, when elliptical orbits are even?
Irrespective of the orbit, if it is circular orbit, no. Elliptical orbit need not be. In some small section of elliptical orbit, if you ask me this is the elliptical orbit and this is the sun, if you ask me work done in this region, then force and displacement will not be perpendicular from here till here. But for one complete orbit it will turn out to be 0 again. Displacement is 0. What did they say, 7th or 8th? What is the ratio of acceleration of black hole to that of the companion star? G capital M small m by r square will provide the required centripetal force. Right? From that you will get that? Nobody asked me this as a doubt till now here. All that you do is G capital M small m. 8th question, take G capital M small m by r square will provide the required centripetal force mv square by r.
Sir, question 14.
Question number 14. If the radius of Earth is decreased keeping its mass constant, effective value of G increases at poles while may increase or decrease at the equator. Here you have to take two things into consideration. Here the language is a bit deceptive. All the students will have a doubt with this. If it's like this. 14. If the radius of Earth is decreased keeping its mass constant, so G is equal to Gm by r square. If the radius decreases, undoubtedly G increases. At the poles I am damn sure about it. But at the equator I have one more point into consideration. What? G phi minus r omega square. Somebody sent me a message. It seems I wrote in the class cos square lambda. Just see in the classroom. It is cos lambda, right? Did I write cos lambda or cos square?
Cos square lambda.
By chance it seems I have written cos square. Rectify that in your class notes. It is just taking the resultant of these two. To simplify you will get the answer. The answer is cos square or cos?
Cos square.
Somebody having HCV?
Yes.
Open up, see the resultant of these two. This is mg, this will be m omega square r cos lambda. This is r cos lambda. Now you are taking the resultant of this. This is pi minus lambda. Root over of the resultant of mg and this. Take, see what you are getting. If it is cos square or cos lambda. Remove lambda totally.
बुकलेट में है सर.
Booklet?
बुकलेट की थियरी में है.
कहाँ पे देख लो. The answer is it cos lambda or cos square lambda?
Sir, acceleration 15th one.
1 second, wait. Okay, do one thing, listen, take the resultant of these two.
हाँ सर.
Cos, rectify this in your class notes, it is cos lambda and not cos square lambda. And remember, you are taking the resultant of these two forces and neglecting the higher powers, that's all. Right? Now listen. What is important for this question is, in your class notes, please rectify this. Remove that cos square and make it cos lambda. Now in this assertion and reason, what is the problem that you have got? The problem is when you are at the equator, along with the G decreasing, G5 will decrease minus R omega square cos lambda. So you will have to find out even the new omega. When radius shrinks, I1 omega 1 is equal to I2 omega 2. Is that clear? So at the poles for sure I can tell you that the G decreases as R increases. Or what did he ask? R decreases, 14th one, right? So G will increase at the poles. But at the equator it will depend on this value. So cos lambda is 1, I don't mind at the equator. G5 is R omega square, G5 minus R omega square. This decreased. As R decreased, G5 will increase. Now balance will remain on it. How do you want me to get omega? I1 omega 1 is equal to I2 omega 2.
Sir, sir, why don't we take Coriolis force into consideration over
I
here?
don't know what Coriolis force is, hence I did not take that into consideration.
Sir, 12th question.
I also remember that as cos square only here.
सर ये देखो
Cos square?
अमेरिकन छोड़ दिया
अरे ऊपर लिखा है
Arey, nahi, it is cos square only. Hey, you wrote the pseudo force. Listen, all of you. What is written is right. This is mg. The pseudo force is m omega square r cos lambda. That is right. Right. Now the resultant will be g5 minus r omega square cos square lambda. This is right. What we have given in the notes is right. Somebody disappeared. No, eccentric disconnect हो गया यार. Left top corner में eccentric disconnect.
Sir, 12th question.
One second. Whatever was written in your notes is correct. Keep it as cos square. And your booklet did not give you a contradicting one. Your booklet says this is the pseudo force m omega square cos lambda. That is cos lambda. What did he say? Question number 12. Solid sphere, radius r by 2, cut, magnitude, gravitational potential, field strength 2. We can directly subtract potential due to the hole from potential due to the whole sphere. The same can be done to find field strength O at O, although potential is a scalar quantity and field strength a vector quantity. Arey nahi yaar. To my understanding, vectors you should always have to take vector subtraction. Why will you just subtract the numbers for field? It will not be so. Reason in gravity it is done like this because for spherical bodies results come out to be the same. It makes no difference whether the field strength is added, subtracted by vector method or by scalar method. No, we don't agree with that. Because field strength you will calculate only using vector addition. How can you do scalar addition? Not possible. Field must always be added or subtracted like a vector. You cannot do the scalar addition for a vector. Now people say if two fields are in the same direction, I will add them or subtract them. Not permitted. You will follow vector law of addition. By chance fields are in the same direction, you will use scalar addition because that is the consequence of vector addition.
So both are false. Both are false.
What is the answer given?
So the first one is true and the second one is false. So the answer is given like that.
Same can be done. Probably he will be right because the same can be done to find field strength at O. He is not telling it must be done. Right? Although potential is a scalar and field strength is a vector quantity. You are adding potential or field here. Inside the cavity, you are adding potential. Say subtracting potential. Field also you will do the same thing. That's what we did also. then statement 1 can be considered to be correct, nothing wrong.
Sir, 15th question of statement assertion.
Radius of circular orbit of satellite is made 2 times. Radius of circular orbit of satellite is made 2 times. Then an area velocity will also become 2 times. Arey nahi, angular momentum will be conserved. If the radius is made 2 times, V will decrease no yaar. If the radius is made 2 times, if this is V, this will become V by 2. I1 omega 1 is equal to I2 omega 2. Conserve angular momentum. Aerial velocity will not become 2 times. Exercise 4. Question number 10. 11th you have done it in class notes. देख लो. 11th.
Yes, sir.
One second. First of all, third thin rod. I'll come. 1 second. This is A. This is L. Potential energy of the gravitational interaction. Consider a small element. This is dm. Minus g dm. You considered a small element at a distance of say x. Minus g dm into small m by this distance.
Sir, in the previous question, why can't we use root gm by r?
Which was the question?
Sir, the figure.
नहीं, angular momentum is conserved. The formula you are telling me is when it is in one particular radius. If the radius is changing, I1 omega 1 is equal to I2 omega 2. You are giving me the formula of under root gm by r in one particular radius. The radius is changing, then I will have to conserve angular momentum there. Right? That is more fundamental. Now this will be the potential integrated from x equal to a minus L by 2 to a plus L by 2. Third question of the subjective one.
So question 5.
Question 5. Particle of mass small m placed at the center of curvature of a fixed uniform semicircular ring. Force of interaction, same thing. Now particle small m, this is capital M. Force of interaction, this is R minus G d capital M small m by R. This will become minus G small m capital M by R.
Sir, 10th.
10th, you people will have a problem in the language used. Right? Understanding the question is slightly difficult. To simplify that language, that will become the hint for the problem. 10th May, what they say is, man can jump over 4 meters. That means you are taking U.
The answer for the fifth one in the booklet is different.
What is the answer? What is the answer?
2gm 1 pi r square.
Fifth one, particle of mass small m is placed at the center of a semicircle, center of curvature of fixed uniform semicircular ring of radius r and mass capital M. I calculated the potential, they asked for the force. I calculated the potential there. Who has doubt with the fifth one? Whose doubt is it?
Yeah, so my.
Listen.
Yeah, got it.
Right. Listen, 10th one, a man can jump over 4-meter wide trench on Earth if mean density of an imaginary planet is twice that of Earth. First of all, on Earth he can clear this. When he is jumping with its maximum velocity, he is jumping at an angle of 45 degrees. So I know the value of u here on g, right? 4 meters is u square, formula for the range, sine 2 theta by g. Now this will be 1. I get the value of u by u square by g. G is? Hey, projectile motion on Earth, kahe ka g is varying? 4-meter wide trench per g will vary on Earth. Right? Now consider this. If mean density of an imaginary planet is twice that of Earth, now g dash will be 4 by 3 pi 2d g, or mean density is 2 times. Mean density of an imaginary planet is twice that of Earth. Calculate its maximum possible radius so that you can escape from it by jumping. Escape from what? Escape from the planet. From here to escape, the escape velocity will be under root 2gr. Say r dash, r dash. He is asking you to find out r dash so that he escapes from this gravity. Right? Now g dash you know. Once you know g dash, this will be g dash. Clear? So in the language, if we give further clarity, that becomes the hint. First of all, your ability to jump is only with the velocity of u. So that ui will substitute here. This is your ability. Now what should be the radius of this planet so that with this velocity when you jump, you escape from that particular planet. Understood the question? Now you will be able to do it.
Sir, 8th and 9th.
Same thing here, 8th question mein, what is the doubt in 8th? Once again, tell me the doubt in 8th. You know the field inside, right? Inside the 8. Do you know the field inside the cavity? Person who asked 8th problem, kindly speak. Don't waste the time of the class this way. Do you know the field inside the cavity? Whose doubt was 8th? Whose doubt?
West.
Please speak. Whose doubt was 8th? अरे यार हद हो गई यार. Are we playing hide and seek here? Please speak.
Sir, Vaishnav.
Tell me. Do you know the field inside the cavity?
Yes, sir.
This field is a constant field. Do you remember that?
Yes, sir.
If it is a constant field, force will be constant. Yes or no?
Yes, sir.
If force is constant, acceleration will be constant. Yes or no?
Yes, sir.
S is equal to half at square. If the particle is released from here and it should come till here, this distance r by 2 is half at square. Is the logic clear?
Yes, sir.
Perfect.
Question number 7.
Wait, he said 8th and 9th. A certain double star. 9th, have a look at binary star system in the notes. It's exactly the same. Binary star system. Only difference, he converted it in terms of density and not mass. In the formula that we have calculated, replace mass with density. 9th problem. Right. Now 7th problem. Gravitational force of interaction between mass m, force of interaction and a thin rod. See, this is mass m. The distance from here is taken as x. This distance is d. Lambda is equal to lambda naught by x. Right? He wants the gravitational force of interaction. Consider a small element at a distance of x. df g dm m by x square. G dm is lambda naught by x into dx into small m by x square. This is df. Integrate this. Least value of x is d. Maximum value of x is infinity. That's solved in the class. Have a look at it. 11th problem is solved in the class. Class notes. Conserve angular momentum and energy. The particle will go this way. This will be V perpendicular to R plus H. Right? Did we deal with this in the class?
Yes.
Look at your class notes. Now listen. What's the time? 8:30. Now listen. I am told right now that SHM ka kuch problems are pending here. Right? Next class, please bring SHM's doubts and HCV gravitation. We'll give 1 hour for doubts, they'll be over. Is that clear? Force equal to M into?
E and M into M.
Sir, did you give any assignment on gravitation?
No, not yet, not yet. I'll give you.
Sir, can you please give, sir?
Sure. Capital E can be equivalent to B and acceleration E. Yes. No, field originally was defined in electrostatics. That we used in gravitation.
Sir,
No, electrostatics
sir,
means
instead of sending,
small g doesn't exist.
so instead of sending photos, can you send the PDF of the assignment?
Sure.
Thank you, sir.
Next class, don't forget to bring your SHM doubts, pending doubts of SHM, and hey, kahe ka 12th, right? And gravitation, HCV.
I have a doubt in the exercise 5.
Exercise 5, please refer to old JEE solutions. Almost in every possible source you have it. If you are stuck up after seeing the solution, please tell me, I will do the needful.
Okay, sir.
Listen. Firstly, when we are speaking about electrostatics, it is a generation of charge. At the first place, Coulomb's law, we tell you force is directly proportional to product of the charges, inversely proportional to square of the distance between them. So I will say K Q1 Q2 by R square, where the value of K will be 9 into 10 raised to 9 Newton meter square by Coulomb's law. Right? K will further be written as 1 by 4 pi epsilon naught. Epsilon naught is absolute permittivity. Its value is 8.85 into 10 raised to minus 12 in SI units. Epsilon naught is also a constant. Absolute permittivity, right? 8.85.
Sir, is there a reason why K is written as 1 by 4 pi epsilon naught?
That's a value calculated. Why will there be a reason?
So, but why do we include pi and all in the formula?
You will understand when Gauss law is introduced. Don't worry about it. First learn the definition. Why 4 pi epsilon naught comes into picture is something you will understand when Gauss law is introduced. Right? Now see. This is 8.85 into 10 raised to minus 12 in SI units. Very first thing, how did they measure this charge? We actually don't know if it is positive or negative. We only knew that there are two types of charges. Unlike charges were attracting, like charges were repelling. How did you come across that? You took a glass sphere or a metallic sphere and you rubbed this glass rod with fur. You rub this glass rod with fur. You will have induced negative charge on this side and induced positive charge on this side. This is a neutral metal on an insulating stand. You bring this close by, right? So this was rubbed with fur, so it acquired one type of charge. Now how did they recognize that there is a different type of charge here? When they grounded this, in the next step, keeping the rod here as it is. Now what happened when you grounded? Positive charge went into the ground. You are left with negative charge here. Now don't commit the mistake of removing the rod immediately. Even the negative charge will go into the ground. Then what they did was, they removed the ground connection, keeping the glass rod as it is, so that this is held charge. Bound charge will never go into the ground. It is only the free charge that will go into the ground. Then remove this particular rod. You will have negative charge spread all throughout this uniformly. They realized that in this situation, while holding the glass rod, you have to apply a force. If not, the glass rod was getting pulled towards us. The glass rod is getting pulled towards us. So then they realized that unlike charges attract, like charges will repel. Can you give two spheres, like charge, and can you give unlike charge? Yes, we can. We will see that. Take it down till here. The values of these constants are important. You are supposed to remember this.
Epsilon naught is in which SI units? Like, what are its dimensions?
K value पता है ना यार?
So, for this example, how did you know that the charge on the glass rod will be positive?
They have named it, nomenclature. They are unlike charges, that's all. So they named one positive and one negative. Harry Resnick is asking, what if I interchange the names? Nothing will happen, everything will be the same. It's like more like telling you people, from today we'll call all the boys as girls and girls as boys. There will be no difference, right? So they called one negative charge, one positive charge.
I didn't understand the meaning of permittivity, sir.
I will come to that. I yet didn't come till there. I will come to that. I will come to that. 2 minutes.
Okay.
by, this was Coulomb's law, K Q1 Q2 by R square is Coulomb's law.
So is F inversely proportional to R square an experimental observation, or it can be inversely proportional to R cube, R raised to 4?
It is experimental. Listen, now when you bring positive charge here, you have got induced negative. Now connect these both, there will be positive charge on this side. Why? I had induced positive and negative here. This was also a metallic sphere. So if I had induced positive and induced negative here, connect them both or make them touch each other. The positive and negative will merge into each other. Then what do? Separate them this way. Separate them this way. Have a look at it. You have separated them. You will have positive charge here. You will have negative charge here. But first, negative charge, I will not remove this directly. There will be induced negative charge here. You separated them, the positive charge becomes uniform. You are yet holding this negative charge. Without removing this, if you remove this glass rod, this negative and this positive would have merged into each other. After removing the connection, separate this so that the positive charge is uniform. Then remove the glass rod. This will be negative charge uniformly distributed. This will be positive charge uniformly distributed. Right? Now, this is the first page introduction in university physics given for electrostatics. Halliday-Resnick is asking, please design a procedure in which you give both the spheres negative charge or both the spheres positive charge. Understood the question? Design a procedure in which both the spheres get like charges. Take this down, make it fast.
So by doing the experiments, how did they identify that positive and negative, or there are two charges, both are different charges?
Do you have Halliday-Resnick with you?
No, sir.
Just see that on the bibliography they write about it. It's a strange history when they worked on it. Right? But basic difference is two charges are attracting, two charges are repelling. So what is the combination? We should have two unlike and like charges.
Yes, sir. Okay.
Fine. Other than that they have no other proof.
सर
हाँ?
सर हम ये कैसे आर्ग्यू कर सकते हैं कि दो ही चार्जेस होंगे? ऐसा भी तो पॉसिबल है ना कि तीन या फिर चार चार्जेस?
Temporarily take only two charges because unless you read particle physics में Meson theory, you will not be able to justify existence of greater charges. Right now we know we have only two charges, positive and negative. Don't worry about their problem.
Okay, sir. Okay, sir.
Sir, in this example, sir, I didn't understand how the positive charge got distributed on the entire sphere. In
Yes,
the second
this
case.
phenomena is called shielding. We'll come to it probably in the fourth lecture from now. Temporarily understand, if I pull this separate, then here why was it only on one side? Because of the repulsion of this. Once you remove the repulsion, bring it out, this will get uniformly distributed. But there is a very strange logic as to why it should be uniformly distributed. We'll come to that in the fourth or the fifth lecture.
Sir,
Sir,
in the first diagram,
listen, we have not defined anything till now. Relax. All your doubts will be cleared as you keep hearing. We have defined only positive and negative charge. Let the class go ahead. You will understand everything. Be rest assured. Trust me. Right? Now, how do you get the same charge on both? This is a negative, this is positive, right? This situation. Now what do? You will ground this. This positive charge will go into the ground. Then what do? This is positive, this is negative. Now you have grounded this. Right? Once you have grounded, this positive charge will go into the ground. So now, keeping them in contact, I will remove this positive charge. I just skipped one step, I should have kept it as it is. It's okay, I'll draw it once again. Now when I remove this, both will acquire negative charge. Separate them, the negative charge will be uniformly distributed all throughout both the spheres. Clear? This is the way you will give like charge to both of them. Quick.
Sir, on the left hand side, sir, I did get it, sir. In the first case, on the right sphere, extreme right में positive charge है और वही sphere में left में negative charge है. So when you connected them, sir, even the negative charge could
This
have,
negative charge is bound by this positive charge. This negative charge is held by this positive charge. Bound charge cannot move.
Sir, on the right sphere, sir.
Right sphere, this is not bound.
Sir, right sphere में on the right side there is positive charge and on the left side there is negative charge. So, sir, when you connected them, sir, even the negative charge could have been distributed.
Here the positive charge and the negative charge will merge into each other. There is no problem for that, right?
Okay.
This negative charge is held by this. This positive charge is not held. So if I ground it, it will go into the ground. I didn't ground it, it remained with the sphere.
Okay.
Sir,
Oh.
sir, in the right side, the electrons will come from the earth and nullify the positive charge. And wouldn't the electrons from the left sphere would also go into inside the earth? It is connected to
If the rod is removed, this is bound charge. Bound charge will never go into the ground. It is held by this. Keeping the earth connection, if I remove this rod, the negative charge also will go into the ground.
So when the glass rod is brought next to the neutral metal, why does it induce a negative charge in the neutral metal?
See, in a metal there is surplus charge available. So there will be negative and positive. When I bring positive charge, it attracts negative charge. So it pulls it to the left. It pushes the positive charge because it repels the positive charge.
Okay, thank you, sir.
sir.
Yeah,
Can you explain what exactly you mean by bound charges?
held. Bound charge is held by this. It is bound by the positive charge force of attraction.
Okay.
Now please pay attention and listen to this concentrately. Andheri, settle down, listen to this concentrately. Firstly, right now you told me force between two charges is 1 by 4 pi epsilon naught q1 q2 by r square. R is the distance between them. Something important is being covered, please concentrate. We will define something called a dielectric medium. Temporarily, in colloquial language, I mean an insulator. Will all dielectrics be insulators? Yes. Will all insulators be dielectrics? No. Right? All dielectrics will be insulators. What is a dielectric medium? Dielectric medium constitutes dipoles. Di, the Greek representation is 2. The Greek representation is 2. If I take a dielectric medium, it can constitute dipoles like this. Any medium which can constitute dipoles this way will be called a dielectric medium. How do you generate these dipoles? Look at the molecular theory here. This is the atomic structure. I got electrons going around the nucleus. If this is subjected to an external electric field, now what happens is the negative charge is attracted towards the positive charge. But the difference between a metal and a dielectric is that in a metal the outermost electron can be easily ripped open. In a dielectric it cannot be. Hence, all the negative charge will appear to be concentrated at one point. This is what constitutes a dipole. Such type of dipoles in a medium will be called a dielectric medium. If ever I subject a system to an external field here, this is beautiful diagrammatic alignment which generally is not possible in solids. Such as proper alignment is not really feasible in solids. In liquids, such a proper alignment is feasible. In solids, maximum there will be something close to this. But this is a textbook representation, an ideal situation. This alignment will make it a proper dielectric medium. Right? Where does this dielectric word come from? It comes from dipoles. Greek representation of di is 2. But then a dipole should always constitute a negative and positive. Clear with that? Quick.
Sir?
Yeah?
Sir, could you please repeat what you were saying about dielectric medium and insulators?
All dielectrics are insulators. All insulators need not be dielectrics, because for me an insulator which can form Dipoles alone are called dielectrics.
Thank you, sir.
Sir, how did you link the liquids and the dielectric part?
How did I link? I didn't link here. Makeup किया है.
So last में आपने क्या किया sir? Last diagram में?
Dipoles, when subjected to an external field, they get aligned in this direction in any dielectric. The only thing is that in a liquid this alignment is possible and feasible. In solids such a systematic alignment is not possible.
Okay, sir. Sir, why sir?
क्या बोले यार आप इसको?
Why means solid there will be lot of friction for the dipole alignments, no yaar. In a solid can you change the lattice structure easily?
No sir.
In liquid you can easily change that.
So why can't we rip out the electrons in dielectric medium?
क्या पूछ रहे हो यार आप लोग, एक बार सोच लो ना यार. Insulator में can you remove an electron easily? What is that? हद हो गई यार. Alkali metals, what is the ionization potential? Chemistry पढ़ो. Ionization potential for alkali metals is lesser, yes or no?
Yes, sir.
Now, to remove an electron from the outermost orbit, if the energy is lesser, that will be a metal, right?
Yes, sir.
Now, for an insulator to remove this electron, the amount of energy is quite high. Hence, you cannot remove an electron from the outermost orbit. But at the same time, you do not have an ideal insulator in the universe. The best comes close to diamond. Right? The energy that you will have to give will be larger for bigger dielectrics. At some stage, there is no perfect conductor and no perfect insulator. Clear?
Yes.
Now listen, this is purely experimental in nature. You take Q1 here, Q2 here, inside a dielectric of dielectric medium epsilon r. Epsilon r is referred to as relative permittivity. Or dielectric constant. Epsilon r is defined as a relative permittivity or dielectric constant. For any dielectric medium, if I tell you the value of epsilon r, what will you get to know about it? Greater the dielectric constant, lesser is the field permitted through it. Greater the dielectric constant, lesser is the field permitted through it. If I have an external field like this and a dielectric, right, the external field would have been this way, right, but there will be some induced negative and positive charge on the dielectric. They will produce an opposing field like this and they both will cancel out. If the dielectric constant tends to infinity, the field inside will tend to 0. If the dielectric constant tend to infinity, field inside will tend to 0. Where from did you get this negative and positive? The previous diagram you showed to me, there was a negative positive alignment this way. These both will come very close, these both will come very close. I am left with a negative and positive. Right, I will have negative charges on this surface, positive charges on this surface. Quantity of this negative charge here and positive charge will depend on epsilon r. Greater the value of epsilon r, lesser the value of the field. Field passing through it. Right, field passing through it. Clear with that? Now, experimentally they observed that if there are two charges inside the dielectric medium, the force between them will be epsilon naught, epsilon r. Epsilon r is a number. This number will only tell you so many times epsilon naught. That into q1, q2 by d square. That into q1, q2 by d square. That means when these two charges are in vacuum, the force will only be 1 by 4 pi epsilon naught q1, q2 by d square. If the two charges are in a dielectric medium, 1 by 4 pi epsilon naught epsilon r q1, q2 by d square. Clear with that? Epsilon r is relative permittivity or dielectric constant. Quick.
Sir,
Yeah.
so you said there will be a back means the fluid will be in the opposite direction. So sir, can you show it at the molecular level?
This is the molecular level. See that the dipoles will get aligned this way. So these both come close, these both come close. I'll have positive and negative here. So you will have a field in the opposite direction. Right? This is the molecular level for the dipole.
Okay, sir. Thank you.
Now listen. We have a very small controversy at the start of electrostatics. Please pay attention here. The first problem in Krotov with electrostatics is you have got positive charge here, you have got negative charge here. If I introduce a dielectric in between, will the force on the negative charge increase, decrease or remain the same? If I introduce a dielectric in between, will the force on the negative charge increase, decrease or remain the same? First of all, by introduction of a dielectric in between, what is going to change? Force on this due to this will not change because the charges are not inside the dielectric. That force will be the same. But then what change are you expecting? In a dielectric, you will have alignment of dipoles this way. So if these two come close, effectively you will have a negative and positive charge. Quantity of this negative and positive charge will depend on the value of epsilon r. Greater the value of epsilon r, greater will be the quantity of negative and positive charge. Now here when I have got a dielectric placed in between of dielectric constant epsilon r, I have negative and positive, you call this Q1 and Q2. Force on the negative charge due to the positive charge will remain same whether the dielectric is placed or not because the charges are outside the dielectric, and force on Q2 due to Q1 will always be independent of presence of other charges. If there are n number of charges Q1, Q2 and Q3, force on Q3 due to Q1 will always be the same irrespective of the value of Q2. I may have Q2 here, I may not have Q2 here, or I may change the value of Q2. Force on Q3 due to Q1 will be the same. Right? So, force on the negative charge due to this will be the same. Now that you introduced the dielectric, what changes are you expecting? On this negative charge due to the positive charge, there will be F positive. On this negative charge, due to this negative charge, there will be F negative. Right? The negative charge will repel this, the positive charge will attract this. But I have a small problem. Value of this charge and this charge is the same, but the distance of this from here is lesser. So force on this due to the positive charge will be greater than the force on this due to the negative charge. Hence, net force on the negative charge increases on introducing the dielectric. I repeat, listen to the logic carefully. Force on negative charge due to the positive charge was, is and will remain the same. Right? Even whether you have a dielectric here or not. Now that you introduce the dielectric, because of this alignment, there will be positive and negative charge here. This positive charge magnitude will be equal to this negative charge magnitude because this as a whole is one atom. Charge should be neutral. That way this positive charge and this negative charge magnitude will be the same. Now force on this due to the positive charge will remain the same. This positive charge will give you an attractive force on this negative charge will give you a repulsive force on it. But this magnitude will be greater than this magnitude. Why? Because of the distance. So net force on the negative charge increases when you are placing a dielectric in between two charges. Is the logic clear to all?
Yes, sir.
All of you?
Yes, sir.
Quick.
Sir,
Yeah.
if I have Q1 in a medium of permittivity epsilon R1 and Q2 in another medium of different permittivity, what to do?
I'll come to that.
Find a
I'll come to that. said?
That and positive in the middle.
There will be, but that's an insulator. You cannot remove this electron from this nucleus. Dielectric is an insulator. Insulator का definition?
Won't it affect the this thing?
See, these both are cancelling out their effect here. These both are cancelling out their effect here. Effectively, I have got only this and this. Right?
Sir,
Yeah.
so then if we go by the formula 1 by 4 pi epsilon not epsilon
How
r.
will you apply that formula here? That formula is for two charges inside the dielectric. Here both the charges are outside. Do not apply that formula for this.
So the same goes for the positive charge as well.
Obviously.
The force on the positive.
Obviously. Now, here we have a very strange problem. Somewhere 2001 or 2 they have designed this theory. Observe this. They said this is positive charge, this is negative charge Q1 and Q2. What if you introduce a dielectric in between of thickness T epsilon r? The distance between them is D. They asked for force of attraction on this negative charge. Now the logic that is used to solve this is strange. They say, what if Q1 and Q2 were, your problem now is this is vacuum or air, this is a dielectric, this is vacuum or air. Now either I should bring whole of this into one medium called air or vacuum, or I should bring whole of this into one medium called epsilon r. Listen to this carefully. Thane, please concentrate. Now what they assumed is, if Q1 and Q2 were inside the dielectric, the force of attraction between them is epsilon r Q1 Q2 by T square. If Q1 and Q2 are inside the dielectric, the force of attraction between them is this. How long will you sleep here? 2 times you go wash your face and come out. Main concept of electrostatics you have to say. 1 by 4 pi epsilon naught epsilon r Q1 Q2 by T square. If the two charges are inside the dielectric, what if they were to experience the same force in air or vacuum? 1 by 4 pi epsilon naught Q1 Q2 by x square. Epsilon naught to experience the same force in air or vacuum, I should place them at a distance of x. What will x be equal to? T root epsilon r. Now they restructured this particular problem. Q1 minus Q2. This is d minus t plus t root epsilon r. This space plus this place will be d minus t. This Dielectric they replaced with air equivalent of T root epsilon r. This dielectric of thickness T was replaced with an air equivalent of T root epsilon r. Now what will be the force between them? 1 by 4 pi epsilon naught Q1 Q2 by D minus T plus T root epsilon r whole square. The procedure sounds very appealing, but then if you people observe very carefully, what did you tell me previous to this? When I introduce a dielectric in between, the force between them is louder. Epsilon r will never be a fraction, it will be a number. Now in this case, what are you getting? The force is louder. This is contradictory. This procedure is not to be followed. For sure, Kroto will be right. Kroto in his first question told us that the force will increase. Here, if I am right, 2003, Fiji people started this theory. Now seeing them, almost every material, even DC Pandey carried it till 2009. Every material took up this theory. And then, to add spice to it, they started giving you, what if I have got more than one dielectric? This is Q1 and Q2. They started doing this as D minus T1 minus T2 plus T1 root epsilon R1 plus T2 root epsilon R2. Whole of this theory will be wrong, because the force between them when you introduce a dielectric will depend on the nature of the boundary of this. These will be called boundary value problems you will study in your engineering first year. The nature of that boundary, shape of that boundary, alignment of the dipoles, everything will be taken into consideration before we can tell you the forces. Right now we can tell you only one thing. If a dielectric is introduced, the force between the two charges will increase. Nothing beyond that. The value of the force you will not be able to calculate. This calculation is prevalent and present in quite a few materials. If any of the test series is giving you this question, please solve it this way, you will get marks. But remember, JE will never give you this. Fine with that? Now, one student asked me, what if two charges are kept on two different dielectrics? That is also the same situation. What if I would have placed Q1 in one dielectric, Q2 in one dielectric? This becomes a boundary. So the nature of the field going from here till here will be different. So that is again a boundary value problem. But then in the test series, what do you want me to do? Replace this with the T root epsilon r. Replace this with T root epsilon r and go ahead with the same way. You will get the answer which they are expecting, but that will be wrong. Clear? All of you?
Yes.
Wait.
Sir, can you repeat how you replaced the distances, d minus t plus
By the
t?
way, one second. By the way, now you may ask then, where did they go wrong? Agreed that this is contradicting your result. You are telling me force increases and here force is decreasing. Where did they go wrong? The very fact that the two charges are outside the dielectric, you cannot use this formula at all. This is applicable and experimentally observed as a result when the two charges are inside the dielectric. The fact that they are outside should be respected. Now, second, the boys' doubt. They have calculated, if the two charges are inside the dielectric, this is the force. To experience an equivalent force in air or vacuum, there will be remote epsilon r here. At what distance should they be placed? So x will be T root epsilon r. Right? So now they replaced this distance and this distance is a d minus t. This distance they replaced with x. This is the air equivalent according to them. They replaced it with T root epsilon r. Clear?
Yes.
Quick. boundary problem means which one?
So if the two dielectric joint.
The same situation. What they are doing is they are assuming this distance to be t. They are replacing it with t root epsilon r1. This distance as t dash root epsilon r1. If this is t, this is epsilon r1 t1. They are replacing this distance with t1 root epsilon r1. This distance with t2 root epsilon r2. The distance between them they are taking as these two. They are replacing this with air equivalent, their logic of air equivalent. Understood what they are doing?
Sir, that right part, can you just explain what we did in the initially upper problem? Yeah.
You want me to explain whole of this again then? Right, listen. You have two charges here and you place a dielectric in between. Your problem is this dielectric is not occupying whole of the space. So what they did is they replaced this with air equivalent. What do you mean by air equivalent? If the two charges were inside the dielectric, this is the force. To experience an equivalent force in air or vacuum, you should place them at a distance of x. So they replaced this with t root epsilon r. So what will the distance between the two be now? D minus t plus t root epsilon r. Agreed?
Yes, sir.
That's the force. You are replacing this dielectric with air equivalent. They calculated air equivalent this way, but what we are explaining is this is wrong. Why is this wrong? This doesn't make sense. The fact that the two charges are outside the dielectric should be respected. You cannot place them inside and find out the air equivalent.
Okay, sir.
So sir, it means that the first step itself is wrong, right?
Right. I cannot assume this at the first place. That's the reason why we are going wrong. Our answers are contradicting.
Sir, I don't understand the concept why it is going wrong. Could you please? The concept, main concept, why is it going wrong?
Concept क्या है यार? Charges are outside the dielectric. The formula you are using is for the charges inside the dielectric. 1 by 4 pi epsilon naught epsilon r formula is applicable if the charges are inside the dielectric. But here the charges are outside the dielectric. Isn't it?
Yes, sir. Thank you, sir. Thank you, sir.
Now listen. We define the first two fundamental quantities. What do you mean by the first two fundamental quantities? In gravitation we define field and potential. Listen to this. You define field in gravitation. You told me force experienced per unit charge, Newton per coulomb. Force experienced by unit charge, unit positive charge, unit positive charge is your field. It's a vector quantity. Units are Newton per coulomb. If I have a charge capital Q at a distance of r, field is kq by r square. Right? If I have a negative charge at a distance of r, here field is this way. Here field will be inverse kq by r square. Because when I place a unit positive charge here, it will be repelled by this, while it will be attracted by this. Negative charge के लिए field will be inverse. Force experienced by a unit positive charge. The other quantity we define exactly the way we have defined in gravitation is potential. Potential will be defined as work done in moving a unit positive charge from infinity to this point. Work done in moving a unit positive charge from infinity to the point. What was unit mass in gravitation will become unit positive charge. Above all, absolute potential is never defined. It will always be potential difference. So you will write work done is delta V into Q, in the sense, if I have got capital Q here at a distance of R, potential will be KQ by R. Here no more will I carry the negative sign. Negative sign will come with charge for me, right? Capital Q R. If I have got small q, potential energy will be K capital Q small q by R. But when will I get a negative sign? Only when there is force of attraction you will get a negative sign. If I have got capital Q minus Q, you need not carry any negative sign. You will get the negative sign by default. K capital Q minus Q by R. K capital Q minus Q by R. Right? Suppose if it were minus Q and minus Q, distance between them is R. Potential energy K minus Q into minus Q by R. You get positive. Remember, you will get negative potential energy only when there is attraction. You will get positive potential energy when there is repulsion. Right? Take it down to
So is it a convention if nothing is mentioned then we have to take the charge as a positive charge?
No, they will tell you in the question for sure that it is either positive or negative. If they are not telling you, they forgot to specify.
So then we can't specify the direction of the field.
That's what I am telling you. They will specify whether it is positive or negative. They will not leave the question that way. If they don't say anything, you cannot assume positive or negative. That means it will be a multiple choice question. You will have to assume for positive and also solve, negative and also solve. Field is always radially outwards. Statement is wrong because negative charge will have field inwards.
Sir.
Yeah, NERUL speak.
Sir.
NERUL
Sir.
speak. THANE wait.
So how will dielectric constant affect the field when there are two like charges? For example, you explained like when there are two unlike charges, the field would increase. So in the case of two like charges, the molecular orientation will not really change. So
You mean to say if the two charges are kept within the dielectric?
Yes, sir.
Yeah, this field distribution will be taught to you in your engineering first year. Now the boy's doubt is, if I take Q1 and Q2, how will the field distribution be? Right now in 5 minutes I will draw lines of force. From that you will get some vague idea. Right? The dipoles will align this way. That will be the direction of dipole arrangement. But how will I learn to draw it? That will be dealt with at a much later stage. Don't worry. But you will get an idea right now in 10-15 minutes. When I keep two positive charges, how will the field lines behave? Will be drawn to you. Thane, speak.
Sir, so the force which we had, the wrong force which we had got, sir, it is not the force between, it is not the force of Q1 due to Q2, right?
Force due to Q1 and Q2 will be the same, irrespective of whether the dielectric is inside or not.
Sir, so it is a force of attraction or repulsion between Q1 and Q2.
That was what was reported. What is your doubt in it?
So what is that F which we had calculated wrong?
Net force on Q2. If you tell me, let me clarify this, be clear about it. If you tell me what is the force on Q2 due to Q1, then it will yet remain 1 by 4 pi epsilon naught Q1 Q2 by d square. D is the distance. Force on Q2 due to Q1 will remain the same whether you have the dielectric or not. Unless and until you place both of them inside the dielectric. Even when you place inside the dielectric, one clarification, all of you please listen to this. If I place Q1, Q2 inside the dielectric, what is the net force on Q2? Net force is 1 by 4 pi epsilon naught epsilon r Q1 Q2 by d square. Agreed?
Yes, sir.
All of you?
Yes, sir.
What is the force on Q2 due to Q1?
Same.
Not same. It will be k Q1 Q2 by d square. I will not have 1 by 4 pi epsilon naught epsilon r. I will have only 1 by 4 pi epsilon naught. Listen to me carefully. This is the net force when two charges are inside the dielectric. Net force. While force on Q2 due to Q1 will remain the same. Why? Because the additional difference came because of the dipole alignment. That created the additional difference. Force on Q2 due to Q1 always was the same. Then net force, why are you telling me a different value? Because the dipole alignment will create some additional force on Q2. Is this point very clear to all?
Yes, sir.
The same logic will apply even if the charges are outside the dielectric. If I had Q1 and Q2, that's why, what did Krotov tell you? He said there is an induced negative and positive charge. So force on Q2 due to Q1, he took the same old one. In addition to that, there was two other forces on it due to these two. This will be small f positive, this will be small f negative. Small f positive will be greater than small f negative. Is this clear?
Yes, sir.
All of you?
Yes.
Hence, this is called principle of superposition. Force on this due to Q2 is independent of all the other forces on Q2. Q2 there may be n number of forces here which will exert a force. Net force on Q2 can change, but force on Q2 due to Q1 will remain the same till when you do not change Q1 and you do not change the distance.
Sir, if asked for the net force on Q2 by the dielectric, so that would be the difference between the two.
That would be, but you right now you cannot calculate because you don't know the distribution of charge on the dielectric. You don't know the way charge is distributed. Positive and negative. If I keep a dielectric, the quantity of charge here will not be uniform, right? Here I will have greater charge. Here I will have lesser charge. So how can you tell me the force due to this negative charge on this?
It should be the difference.
Should be the difference, but what the value is you will not be able to state.
Sir, can you please repeat why you said that epsilon naught can't be a fraction?
Epsilon r values refer to any of the table. The mica sheet is 11. It is a relative number. It will tell you so many number of times epsilon naught. Epsilon is epsilon naught epsilon r. Epsilon r is a number.
So what's the range of epsilon r?
Pardon?
So,
Range of epsilon r from 1.11 to almost 8,000-9,000. Ceramics has got 8,000 to 9,000 value.
It can be less than 1.
It will not be less.
sir, so why can't the permittivity be 2.5 times epsilon naught?
2.5 times. Somebody having HCVC, the value is available. Somebody having HCVC, the value is available. Look at the tabular column of dielectrics, you will get that.
Sir, the more value of epsilon r indicates more number of dipoles or more charge on dipole.
More availability of dipoles. More of availability of dipoles. Greater the epsilon r, greater will be the availability of dipoles.
Sir,
Sir,
if one charge is inside the dielectric and the other charge is outside, then what will be the formula?
you will not be able to deal with that right now. That's what I explained. If one charge is inside the dielectric, you will have to find out, according to that wrong theory, you will have to find out the air equivalent of this distance. But that will be wrong. These are called boundary value problems. You will learn in your engineering first year. Now leave it and come to what is important for you people. What is unnecessary, you people hold on to it for all your life. Right? Now leave it.
Okay, sir.
That is wrong. That is beyond your scope. JEE will not ask that. But that's the only thing we need, ironically. Now concentrate on this. Is this clear till here?
Yes.
Sir,
No, listen. Switch off the mic. Listen. Everything unnecessary will be added. There are few things which we have done in gravitation, which will be a repetition here. We will skip this part. But I will remind you people about this. One problem we dealt with, two masses are released from here. Here I will take Q1 and minus Q2. When they are released, when they come close, what will be the kinetic energy? Loss in potential energy will be equal to gain in? Right? What if one mass is fixed and the other charge is released? Loss in potential energy is gain in kinetic. Potential energy, remember, you will not carry a negative sign on your own in electrostatics. Clear with that? Second, if you remember, we said this was minus Q. This was impact parameter. Given a velocity, this way will turn. What did we tell you? Conservation of energy, conservation of angular momentum. Same logic here. Right? Do not miss on it. Third, I am skipping this part because it is exactly a repetition from gravitation. If I have got capital Q fixed here, this is fixed. Small q with a negative sign kept at the center, when displaced this way, will have force of attraction and hence it will perform. You calculated its time period in gravitation. Now in electrostatics, one more problem will add up. Capital Q is kept and fixed here. Small q is placed at the center, this is plus. Now this will be moved to the right by a small distance, x much lesser than d. It will be repelled by this to a greater extent when compared to this repulsion. So the body will come back to equilibrium and hence it will perform. You will calculate the time period. Why are you not solving this in the class right now? You have it in HCV.
Sir, so why will it perform an SHM?
Let the class go ahead. Capital Q, small q, displaced by a distance of x. This is D, this is D. Repulsion due to this on this. Net restoring force is equal to K capital Q small q by D minus x whole square. That's the repulsion between these two. Minus repulsion between these two, K capital Q small q by D plus x whole square. Right? Now this will be D square minus x square whole square. K capital Q small q. Right? This will be equal to mass of this is m, mass into acceleration. Numerator, it will be 4 dx. Right? Now acceleration will be K capital Q small q by m into d cube, because d in the numerator, x is very small when compared to d, d4. Now d gets cancelled out, 4 comes here into x. Now my requirement for a SHM is, if A is directly proportional to x, it will perform SHM. Whoever asked this doubt, come to the front and take 10 sit-ups. Catch your ears and take 10 sit-ups.
Sir, don't the charged particles lose energy on acceleration?
Did I teach classical electrodynamics to you? No, right?
No, sir.
I haven't yet come till there. Quantum mechanics will give aberrations in this. Tomorrow I will tell you uncertainty you will not be able to find out the position simultaneously. So you cannot prove A is directly proportional to X due to uncertainty principle. Isn't it? Uncertainty tells me I cannot find out the position and momentum simultaneously. How are you finding out the position simultaneously? Answer. मत लोगे यार, हर प्रॉब्लम पे रिसर्च कर लोगे. Till now we didn't go till there. Don't try to evade your 10 sit-ups. All 10 sit-ups I need at the end of the class. Now quick, take this down. Andheri, quiet, quiet. There's a lot of noise in your room. Quiet. Third bench. I'm trying to be over ambitious to cover one part in today's class here. That's the reason for my frustration. I want to finish electric field lines, and you people are challenging my speed. Now listen. In gravitation we have defined field potential. What we have not defined in gravitation is field lines. What we have not defined in gravitation is field lines. This is a bit messy. I will not be able to complete the concept of field lines in 15 minutes. Your next class is at 10:30, right? We can stretch it by 10 more minutes?
Yes, sir.
Okay. That's what I was actually worried about. So I was trying to pull it ahead. Listen. Field lines is an imaginary concept. It's not real. Actually, do field lines exist? No. They are imaginary lines. Path followed by a unit positive charge. Path followed by a unit positive charge. Imaginary lines of force. Smooth curves. There will never be sharp bends. Smooth curves which never intersect. Which will not intersect. Why will they not intersect? Because tangent drawn at any point will give the direction of field. Field is a vector quantity. If I have an intersection of two lines, at the point of intersection, I can have two tangents. Hence, I can have two directions for a field, not permitted. Most importantly, they will never be closed loops. You will never have an electrostatic field line to be a closed loop. Right? The reason for this will be explained, probably not in today's class, next class. Right? Greater the density of lines, greater the magnitude of field. Last but not the least, field lines are from higher to lower potential. Field lines are from higher potential to lower potential. Take this down, at least we'll cover 3 points in today's class.
Sir, why should it be a unit charge, sir?
That is the way we defined unit positive charge. It can be an infinitesimally small charge also. That doesn't affect our problem, because when you are defining a field, if I have got capital Q, R, field is F by the small q. K capital Q small q by R square by small q. Hence it is independent of the charge that I am bringing. Hence the charge can be as small as possible, we don't mind.
बच्चों ने डिसाइड किया हम भी देखेंगे कैसा आगे बढ़ेगा. Generally, I don't come to the class calculated that today I'll complete this part of the syllabus. Right. Today I came to the class affirmative that I'll finish at least electric field lines. There is a reason for that. Now the problem is, what is today's date? 14th. Now from 25th you people have vacation. Now I cannot leave a topic in between. Nor can I waste your time for the next two to three lectures doing nothing. So I have to complete one subtopic of electrostatics before you go for vacations. Now you understand my frustration.
Yes, sir.
If not, you'll go for vacations and come back and everything will be new for you. We'll have to revise whole of this again. So before 25th I need to complete one subtopic. I cannot leave it half the way. मेजर टेस्ट से पहले वो भी ये टॉपिक मेजर टेस्ट में नहीं आ रहा है, उसके लिए एक्स्ट्रा लेक्चर होगा तो आप लोग आएंगे नहीं आएंगे. I know you people better than you. That too, this topic is not there in the major test. Listen, firstly, if I have a positive charge, the field lines will be like this. Path followed by a unit positive charge. So if I keep a unit positive charge, it will be radially outwards. If I keep a unit negative charge, the field lines will be radially inwards. If I keep a positive and negative charge this way, tangent drawn at any point will give me the direction of the field. Right? What if I have got positive and positive charge here? The field will be 0 here. Field is 0 means it should be a null point. Field line should not be passing through that. Right? The field lines will go this way. Don't let the field lines intersect. Right. To highlight one concept, have a look at it. Point 1 and point 2. Density of lines here will be greater than the density of lines here. So magnitude of field at 1 is greater than the magnitude of field at 2. Field lines go from higher to lower potential. So potential at 1 will be greater than the potential at 2. Right? Suppose if it is negative charge 1 and 2. Magnitude of field at 1 is greater than the magnitude of field at 2. But potential of 2 is greater than the potential of 1. Field lines go from higher potential to lower potential. To highlight one more concept, this is the way HCV gave one problem. He says these are one stage of hypothetical field lines. Such field lines generally will not exist. He gave this as point 1, point 2, point 3. Density of lines here is greater. Magnitude of field at 1 is greater than the magnitude of field at 3, which will be greater than the magnitude of field at 2. Field lines go from higher to lower potential. V1 greater than V2 greater than V3. Clear with that? We covered the first 2 points of
the field lines. Quick, I know you will take surplus time to draw these lines, no? Vengeance taken is always on one side. It's not that we are in a hurry to complete the syllabus. I just don't want to leave a subtopic before 25th day.
So the lines indicate that if a positive charge is placed somewhere, then it will follow the path drawn by the lines, huh?
There is a small subtle point. I was just praying that nobody asked me this doubt right now, because it will be difficult to answer that at this stage. But now that you asked, listen. As far as this is concerned, that's one of the reasoning question asked in HCV. The question put up is, will the positive charge left free always follow the path of an electric field line? That will be true only in these two situations. Here it will not be, because here when I draw a tangent, it will be like this, right? It will be subjected to a force in this direction, hence acceleration in that direction. Then slowly from there again it will bend. So the path followed will not be exactly this. Then how did you draw this path? If you people recollect, magnetism in schools you might have done this. You might have kept a bar magnet, you take a small compass. The compass will be showing you this direction. Put a dot here, put a dot here. Then again bring the compass here, put a dot here. Bring the compass here, put a dot. That way you connected them. So here, indirectly, if there is a charge, the direction of that is taken as a small line, and such directions are connected to draw a line. So if you leave a positive charge here, it will not follow this path. It will go slightly outside and come. Why will it go outside? Because the direction of the force will be in that direction. But here, you leave a positive charge, it will go straight along the direction of the line of force. Clear with that?
Yes.
Next class, please bring HCV's doubts of gravitation and the last exercise booklet of SHM. I was under the impression that I finished that last exercise here. I don't know. Anyway, probably yours is only the last section left over with those doubts. Let's finish up.
So that's only 20 questions.
Out of it, some of them I have done in the class.
Yes, sir.
Most of it. I know it will be asking for too much, but to ask is my right. Please read the text of Halliday-Resnick crane. I haven't done much in electrostatics. I know you people are laughing because major test is ahead, but then 1 second listen to me. I have only defined Coulomb force and definition of field. This is only 1.5 page in Halliday-Resnick. Right? Please read that 2 pages. It is not that big a deal. We have defined Coulomb's force and field. We haven't completed field lines. So it's hardly 2 pages from Halliday-Resnick. Dadar, are you listening to me? Switch on the mic. Second bench, tell me what was the instruction. Second bench.
So to read Halliday-Resnick and crane, we've only done 1.5 page of it.
Right, so you will read and come in the next class?
Yes.
Louder?
Yes, sir.
Okay. We'll continue in the next class.
Thank you, sir.
Thank you, sir.